the lesson.
Introduction to Power and Mechanical Efficiency. A person has to expend energy in order to climb a mountain, but how quick he does it depends on his power. When two people with the same mass climb the same mountain, they do it at different rates. This means there is a difference in the rate at which they do work. The rate at which the work is done is called power. We have already learned about work done, energy, and conservation of energy. Now, let us learn in detail about power and mechanical efficiency. In this lesson, you will be able to learn the concept of power, learn to use the formula for average power and instantaneous power, solve numerical problems related to power, learn the concept of mechanical efficiency, calculate the mechanical efficiency and energy dissipated as heat. Click the play button and observe the two men of the same mass climbing the mountain. Comparing the two, who does more work and who has more power? Observe the action and click Answer. The amount of work done is the same, but for the person on the right, the time taken to complete the work is less. Hence, he has more power. Click on power to know its definition. Power is the rate at which work is done. SI unit of power is what? W. Click the play button and observe who has more power for the first 5 seconds. For the first 5 seconds, this person has more power. It is obvious that this person has more average power. Click Average Power. Average power, P equals W over T, where W is the work done and T is the time taken. Click Instantaneous Power. Instantaneous power, P equals dW over dt, where dW is the change in work done, dt is the time taken for change in work done. Now assume the person climbs to a specific distance of 10 meters, carrying his weight of 500 Newton in 20 seconds. Drag and drop the values in the appropriate boxes. Calculate and click Compare.
So this is the F is the 500, D is the 10, and the time taken is equal to 20. So this means how much is the answer? So calculate and click to compare. So this means that it will be 500 times 10 over 20. The answer should be 250. Is it possible to key in or not? So we can't key in the answer. So the answer, what from the calculation is 250. Okay.
Summary. Power is defined as the rate at which the work is done. Average power is given by P equals W over T. Instantaneous power P equals dW over dt. SI unit of power is what? It is denoted by W.
Okay, so instantaneous power, what is meant by instantaneous power? That means that the power at that moment. So mungkin ada yang masa yang kita cepat, ada yang lambat. Okay, instantaneous maknanya pada masa itu. Okay, pada masa tertentu sahaja. Okay, bukannya keseluruhan. If or average, that means that is the keseluruhan. Okay.
Change in energy of the car is its kinetic energy. Therefore, P equals half mv squared over t, where m is the mass of the car, v is the final velocity of the car, and t is the time taken to attain the speed v.
So that means that power will be kinetic energy over time. Easiest for general, power will be work done over time, or P equal to any energy over time.
Click the play button to see the car move to a point with specific factors. Click and drag the respective values to their places.
Okay, now we notice that the mass is equal to 800 meter. Sorry, 800 kg. How about the speed? The speed at that moment is 20. 1 over 2 mv squared over the time taken is equal to 10.
Calculate and click compare.
So once we calculate, we will get that it will be 1.6 times 10 to the power 4 watt. So that means that the power used to move the car is 1.6 times 10 to the power 4 watt.
The actual power output of the car is much higher than this value. Can you suggest what other work that has to be done by the car? Work is also done to overcome the friction and air resistance. Summary. The average power of the car in terms of its kinetic energy is given by P equals half mv squared over t, where m is the mass of the object, v is the final velocity of the object, and t is the time taken to attain the speed v. Click the play button and observe the motion of the elevator as it moves up. Can you suggest the factors or variables which affect the motion? Click answer. The factors are tension in the cables and velocity of the elevator. If any of the factors increase, more power is required to move the elevator. Instantaneous power can be expressed as shown from the definition of power as rate of work done. Instantaneous power P equals dW over dt. Since dW equals FdS, P equals FdS over dt. Since V equals ds over dt, P equals Fv.
So this means that ds over dt will be equal to the velocity. So this means that the power will be equal to Fv. Just now you asked what is meant by the instantaneous power, right? Instantaneous is the instantaneous power is the change in work done divided by the time taken for change in work done. Okay, so that means for certain short time. Okay.
Click on the elevator to make it move up with a constant speed by the traction force F. The power required to move the elevator up can be calculated as shown.
So that means that the power with constant speed without any acceleration, yeah. So that means that power will be equal to Fv. Okay, so sorry, I can't. Okay, this something went wrong. I cannot. Okay. Okay, after show.
Drag
now.
And drop the values in the appropriate boxes to calculate the power. Calculate and click compare.
So F is 3000, V is 2, that means it should be 6000, right? So this means compare, this means 6 times 10 to the power 3 watt.
Summary. The power required by an elevator is dependent on the tension in the cables and the velocity with which it moves. P equals Fv. Click the play button to observe a force F pushing a load on a rough surface. The force F is used in both pushing the load and overcoming the friction between the load and the surface. When the load is moved through a distance d, the velocity gained by the load is v. The work input is the force times the distance through which the load moves. The useful work output is the gain in kinetic energy of the load. Click the play button to observe the work done by the force. The work done by the force is the work input Wi, which equals Fd, where F is the force applied and d is the distance moved by the load. The useful work output by the force W0 equals half mv squared, where m equal mass of the load, v equal velocity gained by the load. Mechanical efficiency is defined as the ratio of work output to the work input. This is given in terms of percentage. Mechanical efficiency eta equals W0 over Wi times 100%.
So this means that what is meant by efficiency? Efficiency is the work output over work input times 100%. In other words, we also can use energy. Energy output over energy input times with 100%. Other than work done and energy, we can also use the power output over the power input times with 100%. As a conclusion, we said that efficiency is the ratio of output to input in 100%, in the percentage.
Let us calculate the mechanical efficiency of the system. Drag and drop the values in the appropriate boxes. Calculate and click compare.
So the F is equal to 45 Newton. Distance moved is equal to 10 meters. So that means it will be 450 watt 450 joule. 1/2 kinetic energy, 1/2 times 90 times with V squared. What we get from the calculation, we will get that 180 joule. Then we get the ratio of the work done. Okay, work done for the work done, output work done. This means output is what the object done, output. So it's 180 over 450. So times with 100%. That means that the efficiency is equal to 40%. What is meant by 40%? That means that 450 joule. Okay, 450 joule energy is given. Okay, but just 180 joule turn to the useful energy. Okay. So 180 joule turns to useful energy, and the balance 270 joule turns to wasted energy. Okay, so this means that some of the energy waste, that means that 60%, a lot, yeah, 60% of energy lost as others energy.
Why is the efficiency not 100%? Discuss and click. Answer. Any transformation of energy is not 100% efficient due to heat dissipation.
So this means that the energy mostly generally lost as heat because of the friction, because of the rough surface, because of the air friction, and so on.
Summary. Mechanical efficiency is defined as the ratio of work output to the work input. This is given in terms of percentage. Work input Wi equals Fd. Work output W0 equals half mv square. Mechanical efficiency eta equals W0 over Wi times 100%. Any transformation of energy is not 100% efficient due to heat dissipation.
So as a conclusion, we can say that power can be defined as the rate which work is done. So power, that means is the work done divided by time, rate of. Next, average power is given by P equal to W over T. Power equal to work done over time taken. Where the instantaneous power, P is equal to change of the work done over change of the time, dW over dt. If average power is total work done over total time taken. Instantaneous, that means that maybe there is some change or there is a small short time changing. So that means that we calculate the work done in certain time. And SI unit for the power is watt, and it is defined as W, denoted as the W. Next, we notice that the power will be equal to 1/2 mv squared over T for any moving object. If an object is moving, that means that it consists of the kinetic energy. When the kinetic energy divided by time, rate of kinetic energy will be the power. Ladies and gentlemen, okay, the power required by an elevator depends on the tension in the cable and the velocity with which is moved. Either move up, move down, different story. And the power, if for an object moving with constant velocity and with a constant force, that means P equal to Fv. P equal to Fv, that means that there will be no change of the speed, constant speed. Mechanical efficiency is defined as the ratio of work output to the work input. This is given in terms of percentage. And work input normally is the FD. And work output is the 1/2 mv squared if the object is moving. Okay. And mechanical efficiency given by the formula of W. O, that means that output work done over input work done times with 100%. Any transformation of energy is not 100% or less than 100%. Okay, it's due to the heat dissipation. That means that if the energy output is less than the input, that means some energy loss. That means here any transformation is not 100%. More accurately should be it's less than 100%, because it's not 100%, maybe 101, 110, right? Impossible the energy can be more than 100%. Why? Because according to the principle of conservation of energy, energy cannot be created or energy cannot be destroyed, but it can change from one form of energy to another form of energy. Okay, so that's all. Okay, for the lesson. So